Hey, my name is Jeremy Penner, and this is an off-the-cuff demonstration of the Honeylisp programming environment for the Apple II. I'm going to kind of walk you through the various pieces that I've built so far. Um, just kind of give as quick an overview as I can let myself give without rambling too long. And then hopefully at the end you'll have kind of an idea of my ambitions and what I'm hoping to build. So kind of the first piece of Honeylisp is the Lisp in the name. What does that mean? Well, it means I want to program the Apple II in Lisp, kind of. What it means in practice is that I'm using a Lisp dialect. The one that I've chosen is called Fennel. And I'm using that to generate 6502 machine code. And the way I'm going about that is kind of, well, first, obviously, I start with a 6502 assembler. Seems like a reasonable thing to build. And yeah, this is just, kind of really quickly, fairly simple, bare bones kind of implementation of that. And what this allows me to do is it allows the assembly code really just looks like Fennel lists. You have this list, and these colon here just means like a symbol. So a string, essentially, in Fennel. And so it just looks very much like regular 6502 assembly code with a bit more weird Lispy parentheses noise. But the advantage is that I get to use it as, I have the full power of the Fennel programming language to use as my macro language. This is not a single purpose macro assembler where I am limited to what what capabilities were built in. I can do anything. I can call code that does literally anything. Reads files off the disks, does arbitrary transformations to them, generates bytes, anything I like. This code is actually a 16-bit kind of stack-based virtual machine, kind of a fourth-ish type thing. And this is just defining some kind of simple byte codes or whatever, routines for doing 16-bit math, mostly, and stack transformations. But the nice thing about that is that I don't have to write a fourth either. I can kind of use Lisp as to generate this fourth-ish byte code. So it's a little nicer to read when you have loops and if statements and whatever. It kind of jumps out at you like, oh, here's a while loop and here's where it ends, and like I can see in the editor where the end is. Unlike fourth, which is just a big string of text, which is fine. You absolutely get used to it. I wrote the game that I'm creating Honeylisp to write on the Apple II is actually a port of a game that I wrote for MS-DOS in the past year and a half called Newt Tower, which I did by implementing my own fourth from scratch. So I have a lot of love for fourth. And so this is kind of going from the other direction. Anyway, so that's all nice. And actually my assembly is kind of extensible, so I can add kind of a new bytecode called VM, which will literally just paste bytecode in and makes it a lot simpler to write that. So that's kind of nice. Anyway, kind of the other nice thing is that, like, if I look at my actual game code here and I kind of scroll down, there's like these lines here that append tiles, load tiles, and load maps. What the heck does that mean? Well, that means I have a tiles.json file, which is, just, it's really mostly hex. I could be writing a binary, but I saved it as JSON text, and that way I can kind of, if I want to make copies of something, I could do that or something like that. But actually, The nicer thing about it is that I have a tile editor that is integrated into this editor. So you may have been curious what this editor is. It's a tool called Light, which is written almost entirely in Lua. It has kind of a runtime that goes along with it, because the way Lua works, you embed it in a C program generally that exposes functionality to your Lua program. So it expects that there are, a handful of useful functions for like drawing rectangles and drawing text and a few primitives like that. So it comes with its own runtime, but what I actually did, because kind of one of the very early steps on this project, is I ported it to the Love2D runtime, or kind of game engine. And what that allowed me to do is to use actual like fast graphics routines. So, for this, it's really just drawing rectangles. And I could have done that with the basic Light runtime, but this thing where I'm like compiling that into sprites and generating graphics and using them as buttons, like that's all new. Light really isn't meant to do that, but kind of now that it's ported to Love2D, I can bring everything that Love2D can do into my editor, which is really neat. So yeah, it's nice and you can just like scribble around or whatever, and then this updates in real time, and that's kind of nice. One of the other things that is just kind of super cool is that this editor, obviously written in Fennel, but I have a really I have the ability, because Light is built on Lua, and Lua is a very dynamic language. What I've actually done is integrated a command in the editor to reload a module that the editor knows about. So any kind of command or view or anything that is inside the editor, I can use the editor to make changes and then reload it, and then it's part of the editor. So if I look at the drop background or whatever, okay, well, what's style.background look like? Style.background. So I can say like style.background 3, or like I don't know, style.accent or something like that. Something silly like that. Style accent. And if I hit Alt-R, it says hop swapping editor.tileedit, and now I go to a tile editor, that code changes immediately live. And like, actually, I can I can just like, okay, background 2, do I like that? Do I like background 3 better? They all kind of look the same to me. I guess backgrounds matches the tab, so that's a little bit nicer, and it matches this too, so we'll stick with background. Or like I can say, oh, I want to draw at position 50 rather than 10, and then everything kind of moves over. That's so I can edit my editor from inside my editor, which is really fun, and it lets me obviously iterate super quickly. So obviously, yeah, I have a tile editor, I have a map editor, edit map, which is a little bit less advanced. I actually just wrote this yesterday, start to finish. So it can save a map to a JSON file, but it's not loading it yet, which is fine. I don't actually have scrolling yet. I should implement that. But, you can take whatever, select tile, scribble them onto the map, and then you have a map. So, okay, that's great. So I have all these tools to bring to bear to the problem of implementing this game. And that's great as far as it goes. Okay, I have this nice, integrated editor. I have a really, tight development loop for creating editors. But in the end, I'm still working with an Apple II, which is a very resource-constrained computer. And so, like, what can I do to make things better on that front? Like, I'm still writing 6502 assembly in the end. So I have some ideas about that. So one of the things is I can just, from the editor, boot an emulator. And so that's nice. I have an emulator. Okay, great. But this emulator is a little bit special. It has the ability to open a socket, and it exposes basically a full debugger functionality where I can read and write arbitrary memory, or look at the CPU state, or modify registers, or anything, like literally anything about the running computer. I set breakpoints, whatever I want. I have access to all of that over a socket. So one of the things I can do is I can just say upload. And what that does is it writes my program to the memory of this emulated Apple II. It shows me this little message down here, FB2, which if you miss it, it's in the kind of debug log. And what FB2 means is that is the address of the main function. So if I say FB2G for go, it will run my program. Here it is. So that's kind of nice. I've have been working at this for a couple months. And so I kind of have like the graphics routines in for drawing these tile maps. But I haven't had to think about like how the disk works yet, or like how I'm going to like write a loader to poke everything in memory. I can literally just do that from the emulator and worry about that aspect of the project later, which is super nice. But one thing you'll notice is that I literally just uploaded it now, so my windows are purple. I say, oh shoot, I don't like purple windows, I want blue windows again. So I can just, rechange that color, and then we have blue windows again, as you can see here. I can hit Control S to save those tiles. And then I actually have a hotkey, Alt L. And what that does is it waits for an appropriate time. It sets a breakpoint, waits for an appropriate time in the program where it's basically not doing anything. It's kind of the top of the loop. So it's about ready to start the next frame, and then it writes out an entirely new assembly program. It does the assembly of the new program, whatever you have on disk, and then it uploads it, and then it does whatever massaging it needs to continue running that part of the loop. So like if I change the assembly code, so the main loop is no longer in the same place as memory, my hotcode reload functionality knows how to deal with that. And in the future, I'd like to do things like, keep track of like what parts are kind of RAM and what parts are ROM. So like, oh, if the character position or whatever is in this place in memory, and then it moves to that place in memory, I would be able to read, okay, here's where it is in the old program, here's the kind of state values that I need to save, and then write them back out in their new address. So I want to have like a full hotcode reload, very quick iteration cycle again. And another thing that's nice about kind of having an emulator where I can dump this entire state of the machine is that like I want to be able to do kind of checkpoints, right? Where it's like, okay, well, before I do a hotcode reload, and I take a snapshot of the state of the system, and then if it fails, then I roll back to the old program, which, because I have access to all the state in the system, that's totally fine. Like I don't have to go through a full reboot cycle. Like I can recover from crashes, and it's maybe get some kind of time travel debugging in there. I don't know. I know there are some Apple II emulators out there. I think Micromate has support for time travel debugging. I haven't quite looked into that yet, but that would be really fun. So yeah, that's kind of where I'm at right now. I don't have any like actual gameplay. This is just literally, if you look at the game loop, it's running forever. Here's the hot swap sync checkpoint, and it's just drawing the map over and over and over again. And so that lets me, and like I can, but again, I can like add code here. Like this is not a thing that is specifically, I'm only reloading tile data. Like I can say, oh yeah, clear the graphics on every frame, and then that starts running. And I can say, oh wait, that was dumb. That's really crappy looking, and then reload it again, and then it's fine. So yeah, that's really all I have to show for now. But I'm working on it all the time, and I kind of want to show off what I've been doing, and hopefully people think it's cool. So yeah, let me know if you have questions or ideas or anything like that, and yeah, hopefully I'll have more to share with you soon. Thanks for watching.